field. Writing and publishing a research paper, however, is not an easy job. It needs time, appropriate training, and mentor guidance. That is why we have designed the OmicsLogic Research Fellowship Program to help young researchers as well as students from diverse range of backgrounds to take advantage of the bioinformatic resources for analysis of complex life science data. The fellowship program will offer a combination of online resources and mentor guidance to prepare you and help you complete a bioinformatics project. More details about the program, such as program specialization track, student project outcomes, registration cost, etc., will be discussed during the webinar. We are also joined by one of our former research fellow, Prithvi Vaja, to share her journey from being a beginner in bioinformatics to publishing a research paper in peer-reviewed journals. So before we begin, let me also take a brief moment to introduce you to the team behind the program. We are a US-based bioinformatics company who is working with multiple academic and commercial collaborators to develop easy-to-use analytical tools, and our mission is to make bioinformatics more accessible. As a part of the program, students will have access to the OmicsLogic training that has been completed by over 24,000 participants from 187 countries in over 300 workshops. And due to this fast growth, our team is working with local and regional coordinators that are helping refine our local program logistics and adapting them to the needs of students and researchers around the world. And this training has been completed by participants in 6 different specialization tracks that includes oncology, infectious diseases, precision medicine, neuroscience, data science for biomedical data, and comprehensive training on omics data analysis. Students will also have access to OmicsLogic resources. But how does it help advance bioinformatics teaching? OmicsLogic is a portal for practical and theoretical learning of bioinformatics. It takes a combination of training modules, data analysis tools, curated project datasets, and interactive sessions with mentors to give the student a clear path up the Bloom's taxonomy pyramid. And no matter what the user's initial experience with bioinformatics is, OmicsLogic is a useful tool for gaining a baseline knowledge of the theory behind bioinformatics, analysis of large datasets, and introduction to basic coding languages like R and Python, or even beginning a data analysis project. This also comes with an access to the OmicsLogic courses, which includes courses on bioinformatics, precision medicine, multi-omics that includes genomics, transcriptomics, metagenomics, and epigenomics, data science that includes bioinformatics using R and Python, as well as cheminformatics, and example projects or different fields which you could learn from and replicate for your research work. Users will be given directions to access the T-BioInfo platform for bioinformatic processing and analysis of data. The platform includes demo pipelines as well as data management and analysis cloud infrastructure to run the bioinformatic pipelines. And different stages of analysis are performed in different sections on this multi-omics platform. To view the various courses, example projects, student projects, you need to first sign up on the OmicsLogic Learn portal. Before that, let me walk you through a brief demo on what a completed profile on the portal looks like. So once you sign up on the portal, these are the features that you need to update on your account. That is, a completed profile will have a profile image, full name with appropriate capitalization, link to your social media handles, a brief bio about yourself that will consist of your educational background and research interests. The mentors can view your progress under the Activity tab, and the courses you are currently completing will appear under the Courses tab. Finally, after the completion of your course, the certificates will appear under the Certificates tab. So now you might be wondering what comes after completing the courses and example projects as a part of your research fellowship program. The answer is possibilities are endless. For instance, you could go on to perform a research project like Ghazal Bhargava, a bioinformatics graduate from Amity University, Rajasthan, India, who completed a research project in the field of oncology. She uploaded a project on the Learn portal where an international community of students, peers, and bioinformatics experts can watch her presentation recordings, read through her research project, like, share, and comment their feedback under the comment section. Another interesting student project outcome can be seen in case of Dilara Daikin, a molecular biology and genetics graduate from University of Turkey who completed a project in the field of astrobiology. which she went on to present at the Biomics Club session, a session where an international learning community of bioinformatic enthusiasts come together to share their work, debate on important topics, and share their queries to stay up to date with latest advancements in the field. In addition, she also went on to publish her project as a preprint on bioRxiv that she can share with her peers, mentors, and potential employers for future connections. Further, you also have the opportunity to participate in poster competitions as a part of Omics Research Symposium, like Dr. Uma Yadav, who worked on machine learning project for which she won Best Technical Research Project as well as exciting cash prizes. And this symposium is an international research symposium that brings together experts from diverse range of backgrounds. The student projects are not just limited to graduates and doctorates. For instance, Andre Muedano Sosa, a high school student at Mexico, presented his neuroscience project at the Regeneron International Science and Engineering Fair, for which he won the Potamkin Prize and the 4th award in biomedical and health sciences category. So now, to view the various courses, example projects, student projects, let us begin by signing up on the OmicsLogic Learn portal. For that, I'm sharing the link in the chat box. Please click on the link and I'll walk you through the process behind signing up on the portal. So here's the link to sign up on the portal. All right, so for those of you who are new and wish to create an account on the portal, you can go ahead and click on the option that says create an account. So here you will be asked to enter your name, email ID, and password. You could enter this, or you also have the option to log in using any of your social media accounts, such as Google, Facebook, Apple account, GitHub account, or even Twitter. So with that, I'll pause for a couple of minutes so that the participants can create an account on the portal. And I'll walk you through the process of how you can view the various courses and example projects and student projects on the portal. So until then, if anyone is having any queries, you can put them in the chat. And once you sign up on the portal, please put a yes in the chat box. And if you already have an account on the portal, you can put a done. And so I'll be monitoring the chat box.
Sri Gauri, is it possible to have the links to the specific projects that you shared in the beginning?
Yes, sure. I'll just send it after the navigating the portal.
Thank you.
All right. So I'm waiting for the response from 70 plus participants that are there. Once you sign up, please put a yes in the chat box. If you already have an account on the portal, please put a done in the chat box. All right, we have 2 people who have signed up. Absolutely, that's great. All right, so I'm going to go ahead and log into my account. Since I already have an account, I'm just going to go ahead and click on sign in. All right, so once you sign in, you're able to view the various courses and example projects. So let's say your field of interest is machine learning. So you can simply enter here that asks for looking for a specific course. You can simply enter the keyword machine learning, and that will show you the various courses and example projects that makes use of the machine learning concepts. So you can browse through this list and view it at your own pace after the webinar. So before that, let me also show you how you can update your account on the portal that I was talking about previously. For that, click on the tab that says welcome back with your email ID. So once you click on this, you also have the option that you see here, profile. Here you can enter your educational background, research interest, your name, and you can link your social media handles here. And in my case, I've linked my LinkedIn account and my org ID. So now coming to the how you can navigate through the portal. So under the activity tab, the community manager and the mentor of the program will be able to track your learning progress. Under the courses tab, it will display the various courses that you're currently taking. And once you upload a research project like Ghazal Bhargava, it will be displayed under the projects tab. And if you are enrolling for the research fellowship program, the program will be displayed under the programs tab. And after completing the courses with appropriate assignment and quizzes, the certificates will be appearing under the certificates tab. So now you can also go through the other student projects that are there. So for that, just click on the tab that says projects, and that will display the various student projects that range from oncology, infectious diseases, to machine learning, and so on. So here also you can just enter your keyword like machine learning, and that will display the example projects that are associated with the keyword that you're typing. All right, so I'll share the link to the projects that I was talking about in the chat box. In the meantime, now I'd like to pass on the stage to Ruthvi Vaja, our former research fellow, a student from Navrajna University, Gujarat, to share her journey from being a beginner in bioinformatics to publishing a research project in immunogenetics peer-reviewed journal. So over to you, Ruthvi.
Hi everyone, and thank you for the kind introduction. It's been really long time since I've been here and feels so good to be back over here. So I'll just share my screen. I hope my screen is visible.
Yes, it is visible. Could you please zoom in so that?
Can you see the changing side, because I can just see the white.
Ruthvi, can you please click on play button?
The taskbar is coming in between.
Yeah, can you please click on play button? It will the screen will zoom up.
Is it
Yeah,
fine now?
thank you. Yeah,
So
perfect.
hi everyone. I'm Ritvi Vaja, and today I would be speaking about my journey with Biotech, how I got enrolled as a research fellow. So first, a brief introduction about myself. When I joined Pine, I was an undergraduate student in my first year, and I was doing integrated biomedical sciences. Now I'm doing my master's for integrated biomedical sciences with a specialization in neuroscience. And my interest lies in neuroscience, neurogenetics, cancer oncology, concerned with neuroscience, brain tumors. So I had always this a nostalgic idea about how do I transform my wet lab ideas into dry lab. So then I came across Pine Biotech, and I joined Pine Biotech as a growth ambassador firstly. So after joining as a growth ambassador, I got to know the experts over there. I interacted with Ilya, Dr. Mohit, and the mentors over there. And then I started talking with the research fellows that were enrolled at Dotan. So my duties as a growth ambassador generally comprises of the social interactions, interacting with students and stuff like that. So after joining as a growth ambassador and working as like for 3 months, I then got to know about the research fellowship program that was conducted under Pine Biotech. So then my mentors encouraged me to, join the research fellowship program, and I definitely learned from my peers the outcomes that they were having. So I then firstly developed the topic of interest that I wanted to work on. And as soon as I joined the research fellowship program, I was paired with a mentor. And that mentor was with me from the start till the end of my project. That was for the 3 month duration program. I was always interested in neuroscience, so I took multiple sclerosis. And for your information, I never knew bioinformatics, and I didn't even knew what bioinformatics meant. So first, I had to go through the rigorous coursework that is on the OmicsLogic platform. And trust me, that's one of the best platforms for you to get, inculcated with all these knowledge, because not only bioinformatics, but also all of its branches like genomics, epigenomics, transcriptomics, everything was given. And the coursework, by coursework I don't only mean that they give you the materials for reading. Despite and after the materials, they also have interactive videos, animated videos. They have the performance, web browser, that is the OmicsLogic code platform, in which you can enter your code and see if your results are coming true or not. And they also have exercises and assignments and tests for you to take on your own, so that you can assess yourself on the basis of where you stand and how much knowledge you have acquired. So after doing this coursework, I was asked as a research fellow to find data sets. I didn't even knew how to find a data set or what a data set actually meant. So the mentors over here, they nurture you so nicely. Like, I was ashamed telling them that I don't know data sets and how to find them. But Dr. Mohit, Ilya, and Dr. Harpreet, who was my mentor, they all taught me how to find a data set. And that's on one-to-one interaction meeting. And every Friday, I guess when I was there, every Friday, there was a research fellowship meeting once a weekly. So you discuss your progress. And after discussing your progress, they tell you that, okay, you have done this much. Now these are my doubts. So they help you solve the doubts by hands-on. They share the computer screen, and on hands-on activities, they tell you that this is how you do. And in the next meeting, you show the progress to them. And one of the most interesting thing of the research fellowship program is they don't dictate you that this is how you do your project. It is you who decide what path you want to take. They only are there to guide you that, okay, if you want to do this, this is done this way. And if you want to do this, this is done that way. They never tell you that, okay, we have designed the project for you. Unlike other institutes which tell that, okay, we have designed this project for you and you can go and do it and just submit it. This is all, like a growth process or the process of finding your own way, your own hypothesis. So yeah, that's the intricacy and the expositiveness of research fellowship program over here. So after you get enrolled in the research fellowship program, they train you as a student, and then you go through the process of publication and drafting your research project and everything. So this is my own experience that why I particularly got interested in Fine Biotech Research Fellowship Program and not some other program. That is because over here you get a hands-on experience with bioinformatics tools. Earlier I had seen other places where they give you the coursework and then they teach you through tutorials that this is how it is done, but they don't allow you to perform the exercises by yourself. Over here, I not only had an experience of doing and using all the bioinformatics tools, but I also had an exposure to, using the tools which were on their server, which is the pipeline. And that was so useful. And not only the usage of pipelines by one click, but you even get to know the codes that were implemented in designing that pipeline if anyone wants to go in that field. Now, what happens is in wet lab, if people have experience, it takes years to get one result, or even if you want to find any gene of your interest, it takes years. But if you have an idea from a wet lab and if you want to see in which direction it goes, bioinformatics is one of the best tools to convert your wet lab hypothesis into a dry lab hypothesis and get the result. Over here, if an undergraduate wants to start a research in an early career, I would definitely recommend Fine Biotech's Research Fellowship Program, because it not only takes you through the process of research and hands-on activity, but after you complete your 3 months internship, fellowship program, they even take you through the process of drafting your research paper, publication, and research students knows how important it is for the publication to go haywire. Third is the interaction from mentors. Not only the in-house mentors I got exposed to, but Pine Biotech has research symposium twice a year or once a year. And in that, you get critical reviews from mentors from all over the world and some of the leading universities, which tells you where you stand, how much you need to progress. And I think reviews like that you cannot get on a normal basis, like, hey, I'm emailing a professor and I want a review on this. No one would ever care to reply to your email. But getting involved in Pine Biotech not only helped me to do such things, but also participating in the research symposium helped me to learn from different mentors all over the world how they progress, how they work. And my work also got reviews, which I know, okay, now I need to focus on this direction, I need to move on this direction. I never knew how to write a research proposal or a research paper for this instance, but after completing this research fellowship, when I started writing my first paper, The mentors, really helped me out about how to bring out the layout of the paper, what points need to be addressed, what points need to be included. So it's just not only a project where you just work on a project and leave it. They expect the outcome. Now, the outcome could be in the terms of poster or a research paper. Every week when I say you have to present your progress, you just not say that, mentor, I have done this all things. You have to prepare a PowerPoint presentation and show them, okay, I did these things, these are my results, and these are my difficulties. By doing so, they also are aiming to improve your presentation skills, which is very much needed in this work. So these were the key logistics or the key points I learned from the research program at Pine Biotech, and I really think that it stands out because I don't see any other institutes or companies giving such many advantages in one go. So, just a very brief idea about what my project was. I worked on multiple sclerosis and I wanted to find out the genes that are involved in the memory loss in multiple sclerotic patients, or if those genes are concerned with any kind of upregulated or downregulated pathway. So first at Pine Biotech, when you enroll for the research fellowship program, after you have done your coursework and findings like that, they ask you to plan your research proposal or your hypothesis on which you want to work on, and from there they take it forward. So it's definitely like a whole scientific community, and they do everything stepwise and level wise. It's nothing haywire. So after completing my project, I presented my poster with the same project as the Fine Biotech Research Symposium. So there were mentors from all over the world, and not only this, but my own mentors helped me to design, helped me get through the poster because this was my very first poster and I had no experience sharing a poster before. So I presented the poster at Fine Biotech Research Symposium, and I was very thankful because I won the Best Citizen Science Project Award. So that was definitely a learning phase for me. But then I regained my confidence and like, no, I can really do this. So then I started doing hands-on bioinformatics on my own. And trust me, now there is no going back. Earlier, I was so much, indecisive of, who works with the computers. I was running away from coding. I didn't like all these numbers and stuff, and now I'm like, there's no way without bioinformatics. So after doing the poster presentation, I started drafting my first, research draft. So there were not always obviously one draft. I had to go through the processes. So I wrote my first research paper and then put it on the preprint server. And after like 9 to 11 months, it got accepted in immunogenetics open access journal. So it was declared a few months back. So this was about the entire process regarding how do you go through the research fellowship program and the outcomes. And I would definitely suggest everyone who is over here to try this research fellowship program because it seems that it's just a research, but when you actually go through it, you cannot even count the number of advantages it gives you for your future. Not only this, I interacted with many mentors who were there in the symposium while I was presenting my work, and I had good opportunities to enroll in future programs and stuff like that. So yeah, this was about my journey. Mm.
Thank you so much, Ruthvi. So does participants have any kind of queries related to the research fellowship program? If so, please put in the chat box. So I have one query for you from Anamika, who is our current research fellow. She was not able to join since she is having exams. So her query was that what are the publication charges that come associated with publishing a paper?
So yeah, the publication charges depends on the journal. So for my case, if you want to publish in an open access journal, the publication charges are higher. But if you want to publish in a subscription-based journal, the publication sizes are lower. But again, if you go with the impact factor, that also deviates in its own kind. So I would suggest an open access journal. But if you are starting with a low undergraduate journal would also work. There are certain journals like Columbia Undergraduate Scientific Journal and long-term publishing journals which publish for free in open access. So once if it's very basic and your first research paper, I think you can go with that. And if as and when you progress, I think open access journals would work. It's not that high also, but if you go for Elsevier and things like that, the decision itself takes 1.5 years. So yeah, you can take a call depending upon your requirements and needs.
All right, thank you so much. And another query that we have is, how do you find a suitable journal to publish your paper? Like, you could explain with your experience as well.
So initially, when I wanted to find a journal, I didn't know. I was just applying and submitting to any journals, but then I got this process. So when you go on Google and type down www.journalfinder.com, you get the links for Springer, Elsevier, and other kind of journals. When you open any one of that, you have to paste your tentative research paper titles. You have to paste your abstract and the keywords, and then that search portal would, create the search pages for you. And based on your requirement, to ask that if you want to go for a subscription-based, open-based journal or free publishing journals, and then you can get a list. And accordingly, you can submit. So this is how I used to find journals for my case. And also a second method I would suggest is if you are submitting it to a preprint journal like this, you are asked to fill a survey form, and at the end of the form, you would be asked a question that do you want to receive emails from the journal publisher? So you have to take a yes in that. So if you do so, after a month of submitting your paper on the preprint journal, you'll get a thing like emails on your account saying that, hey, this issue is coming up. Would you like to submit? So I get thousands of emails like that every day, and you would get it if you sign up for that. So based on those recommendations, also you can submit your paper because they are actually inviting you to submit your paper. So these are the two ways I used to follow.
All right. And another query that we have is, what do you look for in the mentor when you're trying to publish your research paper?
So if you're given a chance to choose your mentor, you can choose based upon if your areas of specialization align. I think Biotech has mentors in every field. So you can definitely go with the mentors in which your area of specialization aligns so that he or she can better understand your perspective and thinking. For me, I did not look for similarities because I was very newbie in this field, and for me, learning was the first option. So any mentor would suffice. But over here, you get the best of the mentors. So I don't think there's any condenses on what do you want to choose or how do you want to choose your mentor. You get the best, kind of education from all the mentors. So that wasn't a matter of point for me.
Thank you so much. And another query that we have is, so along the way, you must have come across a lot of mistakes while trying to publish a paper. So what kind of tips and tricks do you have for people who want to publish their paper and they want to get started working on a bioinformatics project? So any kind of advice you'd like to give?
Yeah. So I did not knew the basic format of the paper, that is abstract, introduction, methodology, discussion, results, and conclusions. I would suggest that first read one or two papers and draft your paper accordingly. I mean the topic wise. First is abstract and introduction. Keep your language crisp. I mean, you cannot go on writing paragraphs or stories because scientific papers are crisp and to the point. And third is you definitely encounter language problems, but make sure you don't plagiarize your text. And fourth is try to make your results innovative in the sense that they haven't been published before. That would increase the strength your research paper or the amount of impact your research paper would have on the scientific community. Yeah, these are the key points that I learned during my course.
All right. And one last query is, how much time would it take for you to finalize a manuscript and getting it published?
So after doing the hardcore research, writing took me around 1.5 months. I used to dedicate every day 1 hour for writing. and it came back with corrections when I sent it to my mentor. So obviously that process takes it. If you dedicatedly give time every day, that's 1.5 months. But when you submit and the submittal proposal comes with addition or correction, it takes around 9 to 11 months if it gets accepted and then to get published. So yeah, 1 year you can take into consideration for writing and submitting.
All right. And now there is a question that is, how do we know that the mentor has checked our research paper when we publish it online?
As in what mentor? Okay, so over here you have a kind of, amicable relationship with your mentor. So once you have published your paper online, it's your duty to inform your mentors by email or through Skype that, hey, we got our paper published. So I think they equally deserve to know. So it's our duty to tell our mentors and not our mentors' duty to ask us that is your paper got published or not. So I think that was the question.
And we have a lot of queries about the eligibility. That is, can pharmaceutical professionals also take up the courses and complete a research project?
Definitely, any kind of industry students can take up this project because data sets are not concerned to only biological aspects or machine learning or any stuff for that. You have data sets for all over the, queries and fields. So anyone can take up this research fellowship program.
All right, thank you. And we have one more query. Is this program in bioinformatics? Isha is asking.
Yeah, definitely. The hardcore or the idea behind this project is this program is to learn bioinformatics. But again, depending upon your interest, you can choose if you want to go for transcriptomics or genomics, or you want to work at the epigenomics level, or you want to only learn hardcore coding, that is machine learning. So the call is yours, but the basic underlie is bioinformatics.
All right, thank you so much, Rithi. So does participants have any further queries? If so, please put in the chat box. So that, is bioRxiv a peer-reviewed journal?
BioArchive is not a journal and it's not at all a peer-reviewed journal. It's just a preprint server. Like in case your article gets published in a journal, then it would link the preprint directly to that journal. It's not at all a journal. It's just a server where you get ready-made preprints of the papers which are yet to be published in different journals. So it's not a journal. Don't mistake it for a journal.
All right, thank you so much. And where did you do your wet lab experiments?
I do my wet lab experiments in my university only, but this project is not about my wet lab. I just had this idea to be implemented in wet lab, but again, you have ethics and stuff like that. So I transformed into this dry lab experiment.
All right, and then what are the criteria to get into this fellowship program?
So you would be asked to fill a form if you want to enroll in this program, and the mentors and the administrators would review your application, and you might have to go through one interview, I guess, if needed. And if not, then you will be sent the details for this program, and then you can enroll yourself for this program.
All right, thank you so much, Rithi. We have a lot more questions. These will be covered during the rest of the part of the webinar. So now I would like to pass on the stage to Sonalika for discussing about what are the various specialization tracks and the student projects. So over to you, Sonalika.
Thank you so much, Shri Gauri. And that was a very interesting discussion. And it's glad to see you here, Rutvi, after a very long time. And thank you for joining today's session and sharing your experience with the other participants. Because many a times they ask how all of this would work and will it be beneficial to them? And they have several questions. And today, the idea behind arranging this webinar was more to have an interactive discussion about this program, what the outcomes could be, and who all can be a part of this program. What are the different specialization tracks that you can work on in this program, and also answer other questions, right? So let's get started. But before I start discussing about the specialization tracks, I really want to know the background of the participants who have joined us today. So, what is your background? Are you all students, graduate students, or postgraduate students, or are you researchers? Please let me know in the chat box. And if you're a student, then you're from which stream? Is it biotechnology, bioinformatics, biochemistry, microbiology, or also we have seen interest by medical students? Are you a medical student? I see some responses in the chat. Let's see. Okay, we have people from computer science background as well. That is nice. PhD in mental health. That's interesting. Postgraduate in bioinformatics. So we have people from different fields today who have joined the session. It's good to see. We have a student in BSc Neuroscience as well, same as Ritvi's, postgraduate in biochemistry. All right, this is good to know about all of you. And you all come from different fields. And my second question to you would be, what is your research interest? And do you have a specific research interest because of which you have joined today's webinar? You want to work on a project, your research interest could be a specialization track. Maybe that is what you can tell me in the chat box. Uh, you want to work with the neurosciences in the neurosciences field, or you want to work with infectious diseases or in the field of oncology, genomics. Yeah, you can also tell me about different data types that you would like to work with: genomics, transcriptomics, metagenomics, or epigenomics. All right. And many of you who are students here from bachelor's background, BSc students or BTech students, and sometimes also it happens with master students that they're not sure in which research field they would like to uh, carry out their research project or simply their dissertation to submit in their college. That happens, and it is normal. It is common that it happens, and this session is to tell you about the different fields that you can explore and work on a research project. And if you're a student who does not have a research interest at all, it's all right. We are here to help you out, figure out one, and then work with that particular research topic and excel as Ruthvi did. All right. So without much ado, let's now discuss about some of the resources that you can leverage to either figure out a research interest, or if you have a research interest already, then how can you leverage these resources to learn about a specific type of data analysis that you are interested to learn about and work on your research project. So I will take this step by step. First of all, I want you all to have this link handy. That is the link to the OmicsLogic Learn portal. And on this portal, I'll quickly show you some of the resources that you can leverage and you will leverage as a part of this research fellowship program. So the research fellowship program could either be of 3 months or 6 months. And in the beginning of this program, we take you through a training process, because obviously if you want to work with a specific type of data, be it transcriptomic or metagenomic or genomic or epigenomic, it's important for you to learn about to get the concepts cleared about a specific field maybe, and also to learn about various algorithms, I'll say, or tools that could be used to analyze that specific type of data. All right. And this training period is from a month to 2 months, depending on the duration for which you enroll. Now, this is the courses tab on the portal where you have all of these courses listed out. I won't be going in too much depth of the courses right now, but I'll just give you an overview of what do we have here that you can learn from. So we have mentioned about different types of omics data. That is one thing. I'll just open up one specific coursework and show you the different components that we have put together in each of these courses. So we have three different components that we have put together. The first component is where we have explained the concepts related to that specific field. So we have Transcriptomics 1 coursework where we are trying to explain what is transcriptomics, first of all, what are the different types of sequencing techniques, how do you get this data, and then how do you process this data. And before processing this data, how do you extract the data from maybe public repositories, or if you're a researcher who is generating this data in your lab, it could be a case that you're a biotechnologist and you are generating this data in your lab, but you want to learn how to analyze this data. All right. So we begin from the very basic level, different sequencing types, then what type of data format you need to have, and then how you run the pipeline. Now, when you run the pipeline, what are the biggest algorithms involved in running these pipelines? And I've been talking about pipelines and algorithms. I'll just show you briefly what this pipeline is all about, what these algorithms are all about. And when you run an algorithm, you need to specify some parameters. What are these? On what basis you have to specify them? All of this is mentioned in these lessons. This will help you and guide you run a pipeline and get the required results. Now, when you have your results in hand, it's very important for you to understand how do you interpret biological insights from your results. So again, all of it is mentioned here in the coursework. Now, these are simple learned lessons that will guide you through the conceptual part and will also give you some guidelines on how do you run the pipeline and then how do you interpret your results. Now, there are people who want to learn R coding or maybe use R coding or use Python code blocks to work with such type of data and analyze their results. So then we have some specific lessons, transcriptomics in R or transcriptomics in Python, that will help you and that will help you build this understanding of how you can use the R code block or the Python code block to work with your data, to analyze data and interpret the results that you get. So this was about how different types of course materials can you find here on the portal. Now, again, you can't directly jump into transcriptomics in R or Python if you know nothing about R and Python. You would definitely want to have a basic setup or know something about how to get started with R or Python as a language. So we have some resources for you here that you can leverage. So you will find courses on R and Python as well, where you will learn from the basics how to specifically set up your R Studio and then load data and read DNA sequences. So this is a very basic coursework which will help you get started with this language and also introduce you to various libraries and packages. And then the second coursework that was coming up will take you from an intermediate to an advanced level, where you'll also learn about statistical analysis and various data visualization methods. So this was a very brief overview of what courses have been put together. All right, now in your training, you are required to complete a specific set of coursework based on your interest. And once you have completed this coursework, the question arises, how do I apply the knowledge that I gained from a specific coursework to answer a research question? So for that, we have some example projects put together. So let's say I have now completed transcriptomics training and I want to now see how I could run the transcriptomics pipeline to work with data from liver cancer patients. All right. So this is there we have put together some example projects for our research fellows and also for learners who would like to learn. You can go through these example projects to actually learn how research questions could be answered with the specific type of training that you will complete through these courseworks. And they are really good case studies which will help you build some good background to get started with your research. So that was about courses and example projects. Now, as I mentioned, that when you get started with the coursework, it's important that you have a research interest. And many a times when I meet research fellows in their orientation sessions, so when a student joins the research fellowship program, we basically conduct an orientation session where we want to understand what is the interest the research fellow wants to work on and what are they seeking? Why are they working on a project actually? Is it for their dissertation, to submit in their college as a requirement to complete their degree, or they are doing this to get a publication to get accepted into a PhD program, or if they are a working professional and just working on a project to upscale their skill set. And in that orientation session, I generally meet students from graduation and post-graduation who are confused that what should be their research interest, what they should begin with, and their interest is not streamlined. That is what I can say. So for them, what we have put together is some research project topics, some specialization tracks, and some data types that they could go through for these specialization tracks. So it's a matter of fact that when you complete your training program, after that, you review literature and come up with a research question. But if you are a student and not sure what you exactly want to work with, you can explore this page that we have put together for you. I'll just share the link in the chat. All right. So here we are working on 6 different specialization tracks that I wanted to discuss today about. So I showed you some resources that you could learn from, and majorly they revolve around genomic data analysis, transcriptomics data analysis, metagenomics data analysis, or epigenomics data analysis. And then we also have courses on data science, how to use machine learning for biomedical data analysis. And then you also saw the R and Python courseworks that could be used as a tool to analyze these different types of data. So now we know about these different types of data, and we also know about different types of research specialization fields or tracks, where these different types of data could be analyzed. And we have put together some research questions here under each specific specialization track. The first one is infectious diseases. Simply, it could be you want to work with COVID data. You have some questions put together here under different types of data analysis that you can pick. You can take your time to read through this page after this session is over, and let us know what specific question or field interests you the most and what you want to work on. All right, so back to infectious diseases. Infectious diseases are simply communicable diseases like Ebola or COVID, or also we have some case studies put together on the portal in the example projects that you can go through to get an idea. And we have the example projects linked up here as well. If you want to go through them and see how you can work on these topics, you can go through. The next specialization track that we have is oncology. So here we have various types of research questions that you can answer under different categories of data analysis that is possible. And the list is very huge in number. You can go through each one of these different topics and pick the one that interests you the most. And here we also have the multi-omics integration possible. And also researchers and research fellows have been working with us on structural biology and cheminformatics questions too under the field of oncology. Again, we have the example projects listed out here for you. And the third specialization track that I would like to mention about is precision medicine or personalized medicine. We are currently working in this domain with transcriptomic data, but yes, also there is a possibility that you can work with clinical data, epigenomic data, or genomic data under this category. And then you have agriculture as another specialization track, and then different types of data analysis possible under this specific track. Neurosciences is another interesting specialization track that you can pick. And we have been working extensively on Alzheimer's disease, Parkinson's disease, and also other neurodegenerative disorders, as neurodegenerative disorders are among the most researched topics. So this could be one of your research topic that you would like to work on as well. And the fifth specialization track is metabolic disorders that could be answering some questions related to diabetes. Diabetes type 3 is a topic under research now, and we have few researchers and research fellows working on diabetes extensively. So if you want to join them and work with them in a group, it is possible. And yes, definitely working on the individual research project is a possibility. And the last specialization track that I want to mention is spaceomics. Now, this is one of the most interesting fields that is evolving, and we have some amazing spaceomics research projects that I would like to definitely take you through. I'll just show you these projects that you can go through and see what is the possibility for you to work on such a project. Again, I'll repeat, the link is with you in the chat box. We'll also share it with you over an email. You can take time to go through each one of the research questions or topics that we have mentioned under each type of analysis, under each specialization track, and think of what you would like to work on. And that was it. I did not take up each one of the questions because it would have taken more time. All right. Now the question arises that we have talked about different types of data analysis and specialization tracks. But where do you run these pipelines that I was just mentioning about? I discussed about algorithms, and where do you have all of this data analysis possible? So the answer to that is the T-BioInfo Server. Now, this is the T-BioInfo Server, the hands-on practical server that you will be using to run all the different types of pipelines for different types of analysis. Here you have all these analyses put together in different sections. You have the transcriptomic data analysis section, then the genomic data analysis, metagenomics is here, data mining, and then you have some phylogenetic analysis possible here on the server as well. I can see a question in the chat. I'll just take up in a minute. Or I can answer it now because it's related to the specialization track that we just discussed. So Gibson is asking, every research specialization is interesting. What are the key criteria to consider when deciding which research specialization to go for? Now, the criteria is definitely, the first one is your interest. What is your interest? What you want to work on? The second one could be where in which field you want to do your majors. If you're a graduate student and you want to pursue your master's, it would be in which field? Or a PhD degree, then in which field? What are you interested to learn about? Because it is more important to streamline your interest with the learning. And if you don't have an interest, let's say, if you don't have an interest, though that's a very vague thing, but still, if you don't have an interest, you can maybe pick up one of the research questions that is more under, I'll say, curiosity of the researchers and they're working on, and you think that you would like to add on to the research society by working on that topic, you can pick that. But again, it's the interest that you want to work on and where you see your career going, or where you see your majors, where you see you pursuing your majors into. I hope that answers your question. All right, so now getting back to the server, where I was just showing you the different areas of analysis and different sections on the server. So here you have these drop downs, which will take you to some demo pipelines. Now, before you join a program, if you want to see how the server works and how these different pipelines are arranged, you can create an account on the OmicsLogic Learn portal, and that will help you get an account on the server as well after 24 hours. And then with that account, you can access some of the demo pipelines and see how these pipelines basically work. I will just show you one simple pipeline today, and it would be a very brief pipeline, just to showcase how interesting it is, and to how interesting and easy it is to run a pipeline on the T-BioInfo server, and how interactive the results look like. So here we have a demo pipeline on breast cancer. And this is a demo pipeline where the data is already uploaded at the backend, and we'll just run the pipeline and see what the flow of the pipeline looks like and what the results look like. So I'll just give you a background of what this pipeline is. This is a breast cancer pipeline where you have 10 patients of different types of breast cancers, I'll say. The first 5 patients are ER positive breast cancer type patients, and the other 5 are triple negative breast cancer patients. Now, I'm interested to look what are the different differentially expressed genes among both of these groups, and also then know about the pathways in which these genes are involved. So let's begin with this pipeline. Yes, so there are no prerequisites actually to perform the data analysis, Kishore. And it is not important that you have a software background to run a specific pipeline. We'll be teaching you everything you need to know about a pipeline, what type of data you upload, how you run the pipeline, and how do you interpret the results in the training process when you join the research fellowship program. So you need not have a software background to do so. All right, now getting back to the pipeline, I start the pipeline, and then to look for the differentially expressed genes, I click on the DSEC2 option, and then to look at the pathways involved, I will select enrichment analysis and GSCA and simply end my pipeline. Now, when I end my pipeline, as I told you, it's a demo pipeline. We already have our results put together, and now I'll quickly open these results to show you how easy it is to understand what the results look like, interpret biological insights. Now, we have a list of results that are put together here. We can download these zip folders and extract the files and look at the differentially expressed genes. We have some very interesting plots, and we also have some very interesting TXT files put together where we can see the value of each differentially expressed gene for each and every gene with regards to the samples. So this is a volcano plot that you see. Now these plots are interactive. You can see which is the gene that is differentially expressed, what is the log fold change, and these terms that I'm using, it's not important that you understand it now. We will definitely take you through the training process where you learn about it all. And this is a heat map which clear-cut shows you what is the expression level of different types of genes in different samples. And more the expression level, more different is the expression level, highly is the differentially expressed genes that are mentioned here in the heat map. And then you have some interactive dashboards where you can interact with these results and also interpret what the results look like. All right, so you can play around, you can increase the fold change values, and then look at the differentially expressed genes. And also, if you want to look at the pathways, then you can click on the enrichment button right here, and you'll get these pathways along with the gene ratio, and you'll get to know about what all are the pathways involved here. So that was a very brief overview of how you can run a pipeline, and just to showcase you how easy it is to run this pipeline and then interact with these results. All right. Now, my last question is, what after research fellowship program? So one possibility is definitely, as Rutvi has shown a publication as well and told you, it is the publication that you can get if you dedicate good number of hours to the research fellowship program and work on this program. So here are some of the publications that we have got by research fellows, and you can go through these publications. Here is the link in the chat box. And another outcome could be a publication on the OmicsLogic Learn portal as well. Now, there are many students and researchers who work on a short-term project maybe. And so what they do is they submit their project once it's completed on the portal. And then when they extend their fellowship, they validate their project and then take it towards the publication. So we have all our projects here uploaded under the projects tab on the OmicsLogic Learn portal. And you can go to the portal and look at some of these project publications to see in which all different specialization tracks and with which all different data types our research fellows have completed their research projects. So that was all that I wanted to discuss. I think I'm over time, so I'll be now handing over the stage to Sparsh. And meanwhile, Sparsh shares her screen. If there are any questions, please put them in the chat box so that we can answer.
Thank you, Sonalika, for explaining the research topics, etc., very comprehensively. I guess there is a question. Are these courses paid and do they have certificates as well? So, Sonalika, could you please answer this question?
Yes. Sparsh, I'll take the sharing option back from you.
Yeah, sure. No problem.
All right. So when you join the research fellowship program, the access to the courses is included in it. You get the access to all the courses and all the example projects as a part of the research fellowship program. That is point number one. And when you complete each one of these courses in your training part, so I mentioned that when you join the program, you have to complete training, a coursework, I'll say, in the initial days of your research project to get yourself trained to work on a research project. So when you complete these courseworks, you get a certificate for it. So you will get a certificate for each one of these courses, and you will get a research certificate when you complete and submit your research project on the portal. All right. So where do you get your certificates? This is the profile tab. You need to click on this email address of yours that comes in the main menu bar. And when you click on this, you will be redirected to your profile. Now, we monitor our research fellows' progress and our users' progress through profiles, where we can see what all they have been working on recently. And for completing each of these courses and lessons in these courses, you get some points that will take you from a beginner level to an advanced level. So this is the tab where you get all your certificates when you complete a particular coursework. This is the part where you can see which all courses you have completed. I just started off with some of these courses here. So when you complete a specific coursework, you get your certificate. So yes, you will get a certificate for completing each of the courses and the example project throughout your training duration. And you will also get a research certificate when you submit your research project. I hope that answers your question. Pamela, you cannot access all the lessons in the courses if you are not a part of the fellowship program. You can access the unstarred lessons, which are introductory lessons to give you a sense of a specific topic that coursework refers to. All right, so in the coursework, you have some lessons which are unstarred. You can access these to just have an idea about a specific topic and to see if you want to take up the STAR lessons or not. Thank you, Pamela. Sparsh, over to you.
Yes, thank you, Sonalika. Okay, so hello everyone. My name is Sparsh and I'm the marketing manager here at Biotech. So I'll quickly guide you through the registration steps and the different resources which you'll have access to if you'll enroll in Bioinformatics and Data Science Research Fellowship Program. So here is the landing page of the Research Fellowship Program, and you can go through with this particular page after the session gets over. And if you feel any query, so later on I'll share the email address on which you can ping and we can discuss it further comprehensively. Now moving further, so this is a research fellowship program. As discussed earlier, this particular program is not for only biosciences students. Anyone from any background, whether it is a computer science student or a student from a pharma background, anyone can join this particular program and can start analyzing complex life science data and become versed in bioinformatics. Now, how? So this particular research fellowship program we have designed in such a way that we will be we'll be teaching you, we'll be training you from basics, then we'll be transiting you from basics to intermediate, and then from intermediate to advanced level, and then we'll be guiding you how you can or how any participant can develop a research project after gaining appropriate conceptual as well as practical knowledge based on their research interest. So now scrolling down, so these are the three basic steps, or these are the stages which one need to go through. So the first stage, in a very layman language, the first stage is to get yourself trained. So as Sonalika showed you the OmicsLogic Learn portal, so there are different data types on which you can work on. For example, genomics, for example, transcriptomics, metagenomics, epigenomics. Then there is a new emerging field called space omic. So those who are having interest in multi-omic fields, then there is a field called data science in R, data science in Python, then machine learning. Then we have some specialization tracks like precision medicine, neurosciences, infectious diseases, etc. So based on your research interest, the mentors will guide you which all courses you need to take up and you need to go through so that you gain that appropriate conceptual knowledge which will help you eventually in your next stage, so that you can come up with a good research question, prepare a good methodology, come up with a data set on which you need to eventually work on, and finally develop a research project. So the first thing is get ready through training. So topics what we'll be covering is introduction to bioinformatics and basics of data and life sciences, so that you get to know about the insights or the glimpse of what exactly is bioinformatics, different terminologies, different healthcare applications, and how bioinformatics is being used in translational research, etc. Then we'll be guiding you through omics data types like genomics, transcriptomics, or metagenomics. Then data science and machine learning for non-engineers and biologists, and then R and Python programming and in-depth analytics for complex omics data. So these are the topics which is there in our OmicsLogic Learn portal, and based on your research interest, you can opt one and start learning and start gaining the training. Now, some of the points which you need to remember while you are in your research fellowship program, that is, you should make sure that your research question is comparing to those already in the field. It should be novel. Second, set specific parameters to answer the research question conclusively. Find a data set that fit your objectives and explore them for batch effects or bias. And fourth, get feedback from our expert mentors on your topic and analysis proposal. So in the first stage, you'll get yourself trained. And in the second stage, you will start working by reviewing literature extensively. Then once your research question is fixed on which you need to work on, you'll fix a data set on which you do the analysis. Once your data set is finalized, you'll start preparing the methodology on it that you need to follow so that you can come up with the results and in the end do the statistical or the biological interpretation of those results. And in the end, whatever you have done, you need to prepare a kind of a report or a manuscript so as to submit. Now, what are the potential outcomes of this research fellowship program when you join? Number one is expert feedback and overall evaluation of project quality, innovation, and analysis execution. So you will be getting feedback not only from our Biotech mentors, but also from our industry experts. Now, second is the poster presentation at the research fellowship meeting or a research symposium. So we organize biannual Omics Research Symposium, where our participants get an opportunity to present their research project, what they have done till now, and also gets exciting prizes, cash prizes, after the results are out. So the third is path to collaboration with expert mentors or faculty at partner universities. And the last but not the least, path to a full publication. As you scroll down, you will find three different tenures. Now, there are three different tenures on which one can work on, rather, I would say four different tenures. One is 45 days, another is 60 days, then is 90 days, and then is 180 days or 6 months. In all the four tenures, the resources are, you will have access to the asynchronous courses. That is, you will have access to the OmicsLogic Learn portal, where you will be covering basics till advanced training courses and lessons. Then you will have access to the hands-on assignments. You will have access to the group sessions. You will have access to the OmicsLogic program access, educational cloud pipelines, online mentor support, online technical support, etc. So these are the resources which one would have access to when they will enroll for this particular program. Now, the resources are same, but the outcome is different for all three or four tenures. The outcome for 45 days is a literature review and a project report. Then for 60 days, it's literature review, project report, and a research poster. For 90 days, it's literature review, project report, and a research paper publication. Same goes for 180 days also. Now, the question arises how one can enroll and like the payment checkout links for the research fellowship program and how one can proceed with the payment. So here we have provided with all four payment checkout links. And if anyone is from low income countries, so if the scholarship opportunities are available, and you can reach out to us at the given mentioned email address, that is marketing@omicslogic.com, and we will be providing you with like the best possible way, like helping you out with the best possible way so that you can enroll in this particular program and get started with the training and the research part. So now moving back to the payment checkout. For example, if someone is interested in 45 days, you need to simply click on this link. It will be redirected to the payment page. So it's taking a little bit time. Yeah. So now what you need to do is you need to simply, put some of your details over here, payment information, etc., and click on the payment pay button, and you'll be you will be done with the payment part. So by this, your payment is done, and after as your payment is done, we'll be organizing an orientation session of yours where we'll be navigating you through both the platforms, that is OmicsLogic Learn portal and the T-BioInfo Server, as Sonalika showed you. Now, here are some of the student projects which is being published on our OmicsLogic Learn portal, and these projects are on different domains. As you can see, some students have worked on infectious diseases, some on space omics, some on precision oncology, then machine learning and modeling, skin diseases, data-driven drug discovery, etc. So this was a little brief about the research fellowship program, the resources which one would have access to, the different domains on which you can work on, the different tenures, and the payment process. So if anyone is having any kind of question related to registration step, payment, etc., please feel free to ping in the chat box, and I'll be there to assist and answer your question. Thank you.
Thank you so much, Sparsh. So we have one query from Pamela, that is, she's interested in the fellowship and she's a postdoctoral and she needs to start learning the bioinformatics as soon as possible. So which one would you suggest the best option for her? Is there any deadline?
No, so this research fellowship program, like it's you can say it's active throughout the year. So anyone according to their feasibility can join this particular program for any tenure. So there's no deadline for it. And anyone can learn in any domain. So if someone is into bioinformatics, so the research project can be totally oriented towards bioinformatics and computational biology and multi-omic thing. If someone is interested in infectious diseases, so it can be totally oriented towards the infectious diseases part, etc. Yeah, I hope this answers your questions.
Thank you so much. So does participants have any further queries? If so, this is the best time to ask. You can either put them in the chat or we can give you access to unmute yourself and ask the query. And just as a note for the participants, we will be mailing out today's recordings to all the participants. All right, thank you so much, Pamela. So if you want any links to be reshared once more, you can let me know. We will be happy to reshare. I'll just pause for a few more minutes so that if the participants have any queries, you can put it in the chat. All right, Saksham Bhatia is asking for Telegram links. If Ojasvi or Sparsh, you could just share the Telegram links to the group.
Sure. I guess Shubham is here and he can share the appropriate research fellowship program Telegram link here in the chat box. Shubham, could you please do this?
And we have another query that is, does belonging to a collaborative university have any perks?
Yes, definitely, Anjal. So if a student from a collaborative university joins our research fellowship program or any mentor guided program, so we have a special scholarship for those students. And yes, so like in terms of like payments and all, you have perks. Rest, the guidance and all is similar for all students. Anyone from any university, whether it is a collaborative or non-collaborative one.
Thank you so much, Sparsh. And Ojasvi has shared the links to the various groups that are there, so the participants can take a look at it. And does anyone have any further queries? And another query is, do we have to do the research project in groups?
No, so it's not necessary. You can do it individually. If you have, like, if your colleagues or your friends are with you, you can do it collectively in a group also. It's completely on you if you want to do it individually or in a group.
Thank you so much. And Pamela is asking another query. Do you teach based on the platform you show, or do you teach how to use other tools as well?
Yes, Pamela, we basically work on two different platforms. One is our learning portal and another is our analysis portal platform, that is OmicsLogic Learn Portal and T-BioInfo Server. But if you specifically opt for like a cheminformatics kind of specialization track, so we do teach other tools which are related to cheminformatics background, like Autodoc tools or for QSAR modeling, etc. So we do teach other kind of tools also, which are used for a specific kind of specialization track.
Maybe to add to that, we actually offer the platform as a way to process data on the cloud. But behind each one of those methods, there's some kind of a commonly known published method that is typically used for that type of data. They're packaged on the platform for someone to be able to use them using a graphical interface. But we also have in the lessons that were described, the actual code on how you would call and run that method in R or in Python.
Thank you so much, Sparsh and Ilyasa. So we have another query. When is the deadline for the payment?
So as like November is fast approaching, so we'll be starting our next RF batch from November 1. So it would be great if anyone who is interested in a research fellowship program, so they can proceed with the payment checkout in 2 to 3 days, and they can be enrolled in the upcoming batch from November 1. Yeah.
Thank you so much, Sparsh. Do we have any further queries? If so, please put them in the chat box, and we'll be happy to help. If you're facing any kind of technical issues while signing up, or any kind of queries related to the research fellowship program, you can put it in the chat. Ojasvi. And any book suggestions for undergraduates before enrolling?
No, not particularly, because like our learning portal is sufficient for making you trained what the conceptual skills what you require to do or complete or develop a research project. So no specific book suggestions are there.
We do have some suggestions, I would say. If you go to the portal inside the Introduction to Bioinformatics and the Bytes and Molecules course, which both are free, you don't have to pay for anything to complete those courses and get a certificate. Inside those courses, there's a lot of additional links to different articles, research articles, publications, books. So please take a look at those two. And once you complete those and you have any additional questions, I think we would be happy to recommend other resources if you're interested.
Thank you so much. And Ojasvi has shared some of the links to the courses that we have. So far, if the participants do not have any further queries, we are good to end today's webinar. And we also have another webinar where we have invited another research fellow who has published his research project. And it will be on November 4th, next week. And we'll be sending out the details of the webinar in the email as well. So please make sure to join. And if you have any further queries, you can reach out to the email ID that has been provided in the chat box. So with that, thank you everyone for joining today's webinar. And thank you so much for your patience and have a great day. Thank you.